everyone. In this video, we will be evaluating a given angle, and this is the first part. Now, before we jump into some examples on how to evaluate a given angle, we need to remember these following important information. First, reference angles. Reference angles are angles that are located in the first quadrant. So these angles right here are considered as the reference angle. And then another important information is that this coordinates that we have here, x and y, for each of these angles represents the cosine and the sine of the given angle. So for example, if we have 30, the cosine of 30 is actually this value. And if we say 30, we want to know the sine of 30, that's actually 1/2. So again, the x represents the cosine of that particular angle, and the y represents the sine of that particular angle. Another very important thing that we need to remember is that once we're given angles that are not on the first quadrant, we need to determine what is its reference angle so that we can determine what is the measure of the sine and cosine of that particular angle. And so we need to use these formulas to find for the reference angle. Now let's have an example to better see what this how all of these formula work. So let's take this first example right here. We are supposed to evaluate 210 degrees. So what are we going to do first is that we need to determine where is this 210 located at. So we are going to create that x and y axis right here. So on this axis, we remember that we start from 0, then we go to 90, then this one right here is 180, 270, and one full turn would be 360. Another important thing that we need to write here is that we have to write all students take calculus. So please remember that in the first quadrant, all are positive. In the second quadrant, only the sine is positive. On the third quadrant, only the tangent is positive. And in the fourth quadrant, only the cosine is positive. So then we go ahead and draw sine 210. So angle 210 should be located in between 180 and 270. So I can go ahead and approximate it to be located around here. So I can label this as 210 degrees. So that's 210 degrees starting from the positive x-axis. So the second step is to determine the reference angle. In order that we can do that, since this is on the third quadrant, so I'm just gonna go ahead and write that down here. Okay, so I wrote that this 210 is in the third quadrant, and in the third quadrant, we have a negative sign because it's only tangent that's positive in there. So we're expecting to have a value here of a negative. Again, it's a negative because only tangent is positive on the third quadrant. Sine and cosine would be negative. So then from here, we go ahead and determine the reference angle. So the formula to find for the reference angle on the third quadrant is... Okay, so I actually got this formula from the first slide that we have here. So third quadrant, the reference angle is actually equal to theta 3, so the angle that is given to us, minus 180. So then I went ahead and plugged that formula in here, and I will put the values in. The angle that is on the third quadrant is 210, and so we subtract that from 180. So then we go ahead and subtract 210 minus 180 would be 30. So that means our reference angle is 30. So going back to the unit circle that we started from the beginning here, since we say that this is 30, so we're going to be looking at angle 30 as well on this reference angle. So we're going to look at the 30, and then since we say that that is sine right there that we wanted to know, so that means we are going to look for the y value, because remember, the x represents the cosine and the y represents the sine. So we're looking for this value here. So this means that sine 210 is actually the same as the sine of 30, but instead it's going to be a negative 1/2. So I'm just going to write this as negative 1/2 right there. So this is the value for sine 210. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, the first step is to draw the x and y axis, and we label it. Okay, so 315 is in between 270 and 360. So I can go ahead and write 315 somewhere around here. So I can just approximate it. And so from the positive x-axis all the way here, this is 315 degrees. So then we go ahead and move on to the second step. The second step is to determine the reference angle. Before we can do that, as you can see here, this is located on the fourth quadrant. So I'm just gonna go ahead and label this. Okay, since we have since our 315 is located in the fourth quadrant, in the fourth quadrant, the cosine is positive, which means that we're expecting the value here to be positive. You don't have to write the positive there. It can become invisible. So then we go ahead and determine the reference angle. Okay, so the reference angle is 45. So what are we going to do here is we go back to the reference angle. We're looking for angle 45. So it's this value right here. And since we are looking for cosine, we remember that the x represents the cosine and the y represents the sine. So this means that we're going to look at the x value of 45, and that is square root of 2 over 2. So then I can go ahead and write that up here. Square root of 2 over 2. Again, that's positive because that's on the fourth quadrant. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example right here. So we are supposed to evaluate tangent 135. Again, we follow the same steps. The first step is to draw the x and y axis, and we label it completely. So I'm going to draw that up here. Okay, so I labeled it completely. We have 135 is on the second quadrant, and in the second quadrant, the tangent is negative, only the sine that's positive. So we're expecting our value here will be negative. Now we need to move on to the second step. We're supposed to determine the reference angle. So the reference angle, so I'm going to show the work to determine the reference angle for 135 here. Okay, so we got the value 45 degrees. So when we look at the reference angle that we got here, we remember that the x represents the cosine of the angle, and then the y represents the sine of the angle. But we wanted the tangent. In order that we can determine the tangent, we are going to determine the formula on how we can do that. So I will bring this back, the unit circle up here. And then we're going to look at it to determine what formula do we use, since we're given only x is the cosine and the y is the sine, and there's no tangent anywhere around the coordinate. So what are we going to do is, suppose we have here 45 degrees. So I put a triangle right there. Now we remember that tangent is opposite over adjacent. So I can go ahead and write that up here. Okay, so the general formula for tangent is opposite over adjacent. So in this picture that we have here, since we're looking for 45, so then we can go ahead and say that the tangent is actually, so let's say tangent 45 is actually equal to the opposite, which is y, over the adjacent, which is x. Now, notice this very carefully. We remember that the x represents the cosine of the angle, and then the y represents the sine of the angle. So then we go ahead and say that the other formula for tangent theta is actually y here. Remember, the y represents the sine. So then I can go ahead and say that tangent theta is also equal to sine theta over the x value represents the cosine, so I can go ahead and write that as cosine theta. So these are the two new formulas for tangent theta. So it would work to whatever tangent So going back to the examples that we have here, we can go ahead and determine what is the tangent for this. Remember tangent, the formula for tangent that we got from the slide that we have right here is that tangent is y over x. So I can go ahead and say that tangent 135 is equal to, that's gonna be y over x. And so we go back to the reference angle. Our y for, remember 135 is the same as 45. So the y for 45 is square root of 2 over 2. And then the x is square root of 2 over 2. So we're going to divide that. Now, if we divide complex fraction, remember that we are supposed to flip the denominator and multiply across. So that would be square root of 2 over 2 times. Flip this, that would be 2 over square root of 2. So then we can go ahead and cross out both of these. So we can cross out the square root of 2, square root of 2. And then the 2 and the 2 gets crossed out. So the leftover here is 1. Again, remember, this is not a positive 1 because we're looking at 135. We remember that the tangent on the second quadrant, which is 135, is negative. So I need to write a negative in there. So the value for tangent 135 is negative 1. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. The first step is to draw the x and y axis and label it. So I'm just going to draw that up here. Okay, so I've labeled it. So that's 240. That's located on the third quadrant. And in the third quadrant, the tangent is positive. So then we go ahead and move on to the second step. We determine the reference angle. Okay, so we determined that the reference angle for 240 is 60 degrees. So then we go ahead and look at this value that we have here. We remember that the x represents the cosine of 60 and then the y represents the sine of 60. Since we wanted the tangent, we remember we have come up with a formula for tangent, which is tangent is equal to y over x, or again, the formula, since y represents the sine, I can go ahead and write sine of theta over cosine of theta. Now again, remember, since we have a positive tangent, we can go ahead and write the value right there. We don't need to write a negative on it. So that should be a positive value. So then we go ahead and plug in the values here. So we have our y for, again, we are looking at 60. So it's going to be the same value as 60, so which represents 240. So in 60, our y here is square root of 3 over 2 over our x is 1/2. So then we remember that when we divide two fractions, we flip the denominator and multiply across. So we can go ahead and say square root of 3 over 2, that's the numerator, times. Flip this, so that would be 2 over 1. So then we can cross out the 2 and the 2. So the final answer for tangent 240 is actually square root of 3 because that's over 1. So I can go ahead and write this as square root of 3 right here. So this is the value for tangent 240. Again, it's positive because 240 is located on the third quadrant, and in the third quadrant, the tangent is positive. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example right here. So in these two examples, the values are located on either the x-axis or the y-axis. So let's start with cosine 180. Again, the first step is to draw the x and y-axis and we label it. Okay, since we say that this is located at 180, so it's on the x-axis, remember that this is part of a unit circle. So this whole thing is part of the unit circle. And in this circle, the radius is 1. So then we can go ahead and say that this point right here has a coordinate of, again, remember the radius of this unit circle is 1. So I go ahead and write that as -1 because that's going to the left. And then the y is 0. Again, we remember that the x represents the cosine of the angle. And then the y represents the sine of the angle. So then we can go ahead and say that our cosine 180 is actually, we just look at this value right here. That would be cosine is represented by x value. So then we go ahead and say that cosine 180 is -1. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. The first step is to draw the x and y axis and we label it. So we go ahead and draw that x and y axis right here. So we have already drawn the 90-degree angle right here. Again, we remember that there is a unit circle right here. Unit circle means the radius is 1. So we can go ahead and this coordinate right here would be the x here is 0 and then the y is 1. Because again, remember that this is a unit circle. The radius is 1. So we go ahead and figure this out. The tangent of 90. We remember that this x represents the cosine of the angle and this y represents the sine of the angle. So pretty much there's no tangent. But in the previous slide, we learned that tangent is actually equal to y over x. So I can go ahead and write that down here. Okay, so we plug it in. Our y for this is 1 and our x is 0. Anything that is divided by 0 is undefined. So I go ahead and write this as undefined, which means that this is actually an asymptote. So on 90, there is actually an asymptote once we graph this, once we graph the tangent function. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!